Alright, in this video we're going to explain the dependence of oxygen and ozone dissociation on the wavelength of light. So we're actually just going to look back at the reactions that you looked at, and then we're going to try and describe which one works with which wavelength of light. So ozone is depleted easily because it has a bond order of 1.5 instead of 2, and that is what was discussed before. And thus it takes more energy to break the bond of oxygen because it has a bond order of 2. Now, the energy of light is dependent on its wavelength. So if you have a shorter wavelength, that means that the light has more energy. So what happens is light with a wavelength of 300 to 330 nanometers actually doesn't have enough energy to break the bonds in oxygen since it's a stronger bond. But it is enough to break the bonds in the slightly weaker ozone. So you can sort of visualize this by looking at, again, the formation of ozone. This was one step where the oxygen is dissociated at this wavelength, which is lower and thus higher energy. And then in the depletion phase, ozone breaking down, this happens at a longer wavelength or a lower energy.